in order for something to maintain its independence, it has to have a rich enough description of the external world or the environment, or it'll be controlled by it. So what you're saying is you can't sort of think of an agent independent of some agent in an environment, right? I mean, and that they're trying to model each other. Is that, would there be, and the extent to which they do that, they maintain their independence?
You've stated almost a complete characterization of the free energy principle. So let's talk about that for a minute. The free energy principle is about the conditions under which these boundaries remain stable. A system that remains distinct from its environment must act in a way that preserves the stability of its boundary. Again, we can invoke this symmetry and say that the environment, in order for the environment to remain distinct from the system, it has to do exactly the same thing. Right. Now, think about what actually happens in the case of biological systems. I mean, eventually biological systems, or at least many of them, die. Right. Well, what does that mean? It means that the interaction with the environment changes in a way that keeps the number of degrees of freedom of the system fixed, that increases the size of the boundary so that more and more of the degrees of the freedom of the system become directly involved in the interaction with the environment. So think of your environment as kind of exploding in front of your face. What that does is tear your boundary apart. Right. And make it very big. It exposes what used to be inside to the outside. And that's what happens when systems just kind of fall apart. The environment, when the system's no longer distinguishable from the environment, because its interaction is so strong, the environment's now no longer distinguishable from the system. Right? The system's been kind of sucked into the environment. So the identities of both of these partners have changed. And in the early days, you would have like climbing a fitness landscape. There's this passive thing the agent acted against, but they didn't define each other. And what you're saying is they mutually define each other, and you can't. And that's foundational. And that seems to be very different from your traditional classic scientific perspective or objective reality, whatever. Is that these things are mutually defining and dynamically shaped by the free energy principle over time. It's like, oh, the environment's out there, you act upon it, and then you get something out of it, but you don't mutually shape. So this whole idea of highly interactively, mutually defining things is to me, at least, a very different and profound different perspective on how to look at any form of, quote, intelligence, organization, or agency. And as you say, the interface becomes a critical way of understanding the nature of the interface, and the boundary conditions is sort of key to doing the analytics. Let's just stay in Hilbert's space for a while and think of a system that's interacting with its environment, doing what Carl calls active inference, right? It's trying to learn about its environment. So it has some learning algorithm that allows it to get information from its environment and use that information to update its model of what the environment will do next. But it's also an active agent, so it can act on its environment. In fact, it has to act on its environment. There's no such thing as a one-way interaction. Right? Interaction is two-way by definition. So the system is always giving information to its environment. And we can think of it from the system's point of view of, I'm acting on the environment to see what it will do with the manipulation that I give it, or see what it will do when, remember, for the environment, that's its sensory input, what the system is doing to it. Right. So the system's going to send a message to the environment to see what kind of message it gets back. So the system can actively control the rate of its own learning by acting on the environment to try to generate some novel behavior on the part of the environment. So systems are constantly doing this. They're playing with the environment to see what the environment's going to do. Well, why? Because they want to build a better model of the environment. And simultaneously, the environment's doing that to them as well.